Forecasting using data. This is really what I do. I do forecasting consulting and so forth. Everything you're going to see today, nothing is sold. Everything is just downloadable and free for you to get. So I'll make sure you get the slides at the end. If you miss anything, don't worry about it. We'll find it. I've also got a broken right foot, so I'll wobble around a bit from time to time. So this is what we're set out to do a lot in the software projects, or projects in general, planning in general. You know, we forecast so that we can detect when reality isn't going in the same direction as our forecast would indicate. So I know a lot of people focus on the dates aspects and the money aspects of forecasting. Forecasting is actually giving you the ability to detect earlier than you would have otherwise that things aren't heading in the direction you expected with enough time to do something about it. So keep thinking about forecasting, not about sort of giving someone an answer as to how much or how long or when something will be done. Start thinking about forecasting as giving yourself the tools to get to an answer of a rough directional forecast so that you can detect when things are going wrong. Now, George Boxer's quote is often misquoted. It's probably one of the more misquoted quotes out there. Has anyone heard of the quote that all models are wrong, some are useful? Well, the full quote actually said, remember that all models are wrong. The practical question is, how wrong do they have to be to not be useful? It's about that, what do we have to have? What do we have to use to estimate or forecast something of interest so that it doesn't mislead us? And what are we up against? Oops. We're up against your intuition. Sorry about that. I think I need to stand a bit closer to my laptop. You're up against your own intuition. Your brain. Your brain has any number of ways that it can drive you to the wrong decision. The world that we live in is often so complex, and our brain has to do so much processing that it takes shortcuts. It has different techniques it uses to deal with too much information, has different techniques to deal with not really knowing the true context or the risk. It has a different set of shortcuts that allow you to act fast, to flee from a lion or a tiger that's about to eat you. And it only has a certain amount of memory capacity that it can draw on quickly, so it throws some information away and we get all convoluted and jumbled up. So these are generally known as cognitive biases. Now, if we don't have at least a mental estimate or a forecast about how long something is going to take to do or how much something is going to cost, then we have no second check on our brain, our cognitive biases, to understand where we might have the system wrong. And that's what our forecast and estimating is all about. We need a model just good enough to make sure that we can have a double check on our intuition. And as we get more experience in a field or a market, our intuition gets better, but there will always be cases where it will fail us because it doesn't adapt to context fast enough. So a lot about our forecasting is about just understanding where we're going wrong. So yeah, this is if you haven't seen this before, it's a great downloadable cognitive bias index where someone grabbed all the cognitive biases off Wikipedia and sort of put this drawing together and hyperlinked it together. And it sort of shows you all the different ways where, you know, we're drawn to details that confirm our existing beliefs. We notice flaws in others more easily than ourselves. And all of these, when we set out to do something big, a project or an initiative, as it's now called, thanks Klaus, as we set out to do an initiative, our beliefs and everyone's belief in the room will be affected to some degree or another by all of these different biases, which is why we argue so much, whether it's a 3 or a 5-point story. Who would use Google Maps to navigate? Yep, just about everyone now. I mean, it's pretty much changed. You know, back in my day when I was growing up, you know, we had sort of street directories and maps, and then we went through a phase where we used to print out the MapQuest routes from home, and then you would go off the map and not know how to get back. So now we all carry a cell phone, and our cell phone has Google Maps involved. This is, I live over here in Bellevue, and my wife and I often go to date night in Seattle. Now, before we set off, of course, we hit navigate on the car. Google Maps has had about 10 years of refining how it presents different ways of approaching the same problem of traveling between point A and point B. It has different ways of adapting when things go wrong and there's traffic or there's an accident or some other sort of impediment on our way. And there's a lot of brilliance in the model of the way Google Maps navigates us on making a journey between point A and point B that we can and should be applying in our world of software development. What are they? First of all, it doesn't give us just one option, it gives us three here. There's two main bridges across from where I live in Bellevue to Seattle. One is more scenic than another. So even though the one in blue is often faster, the 520, the other bridge up here, is more scenic. And as we're on date night, as long as we leave early enough, we will always go that direction in priority to the extra 2 or 3 minutes that we could save going the other bridge. Context is key, and there's no way of any artificial intelligence or a computer automated algorithm knowing that this trip is because my wife and I are going on date night that we will want to go the more scenic route. It's always going to give us a suggestion, but Google have been smart enough to present both and leave the decision into the human's hands. And this is what we have to start doing when we think about presenting software forecasts. We often sit down in a room and we argue about the different ways of approaching the problem and the ways we could solve it, and then we just give one final result to somebody. Well, that doesn't allow that other somebody to apply the context that might be needed to choose an alternative that was better all-rounded, even though it wasn't optimal for the team who was assembled at the time. Second thing this does that we need to do, it leaves how long we're going to take as a duration. It doesn't give us a time of arrival. It says that a project or initiative is going to take 6 weeks. It doesn't say we're going to be finished by the 1st of August because it doesn't know when we're going to leave. I have to tell it when we're actually leaving, or it can detect when we're actually moving and start the clock and then give an estimated time of arrival once we started. A lot of what happens when we do estimates and forecasting is we set a commitment and then that date flies past as people are scratching their head about whether they're still going to do it or not, or the team isn't hired yet. There's a lot of reasons why if we can make most decisions that we need to make about option A, B, or C using duration, but what we tend to do is we tend to prematurely convert that to a date, or time in this case. Google doesn't do that. Thirdly, what it does is once we have started, it knows that if traffic conditions change and there is a faster route now because of an accident or some other weather disruption, some of these bridges get closed because of high waves coming across them, it will give us an updated route real time. It will give us an updated time of arrival real time. It doesn't just do it when I'm at home before I hit start and give me a time of arrival. It keeps updating that as we go along. And how often do we do that in our software projects? We start off and then we discover something that we didn't realize early on, but we've already made the commitment of a certain date, so we can't go back on that. We just have to work through the night and weekends to get it done. So we need to think about forecasting our software projects more like Google Maps. So to contrast it, we currently give one forecast even though we consider multiple options. Let's not. When we give people a forecast, let's give them the multiple options we considered, just in case there's some extra context that will break the tie between those and make it a more economically beneficial decision, even though it doesn't look that way to us. Let's stop giving calendar dates when they're not needed and start giving duration so that we can do comparisons between options without actually having to prematurely commit to a date that something might go live. When the original date is in doubt, once we do start, let's not freak out and do everything we can to try and shoehorn it in at the expense of quality and people's lives. Let's know earlier and give us enough time to respond in a way which doesn't have such an impact on people or sanity, I guess. And let's not appear on time until we're not. Let's not just stick to that date. Let's start measuring how much time we have remaining to go, knowing what we know now. So often what happens at the moment is we give a date that we're going to deliver, and then we sort of keep quiet about it, or we raise a red flag saying it's in doubt. But we measure how long we've been going. That's not the right measurement to report status by. The right measurement is how long we have to go. And remember, that's what Google Maps does for us. It tells us how long until we get there. It doesn't tell us how long since we started. It sounds insane when you say it like that. But we often measure how long a project has been running rather than how long we have to go. And that sets us up for some very uncomfortable status meetings. And it makes it really difficult for us to have a healthy relationship. We're now helping people say, you must stick to the original commitment rather than make a better decision. So that's just Google Maps applied to software. Not saying that you should do it. I'm going to give you some alternative ways of doing the type of planning work that you do now that are of less effort, probably simpler models than what you currently do, that probably will give you a better result than what you currently do. Now, I want to stress one thing here, it's that the question, when will it be done, is a very destructive question. Because the when will it be done encapsulate all of those bad points that were on the left of the previous slide. It's saying that we know exactly how we're going to do it. It's saying that we've only got one option and we're sticking to it. We're going to do everything we can to hit it. It doesn't open up the dialogue that's required in a really risky field like software development, when we don't really exactly know all the details until we dig in and we actually start developing. We learn a lot as we go. There are three better questions that we can have or should have. It's, when do we need it? How can we achieve that? And what don't we get if we do this instead? They're the business interactions that you need to sort of start building up to actually have the productive conversations early enough that you can actually work out what scope is really needed, which value is going to be delivered by what time. And to answer those questions, there are three core competencies we need to be able to learn how to do. We need to be able to quickly assess how big something is, how big a piece of work is. We need to be able to quickly compute how long it's going to take to do that work. And then we need to be able to say, by a certain given date, how much of that work is going to fit. And we can do all of these three things using historical data rather than estimates. And historical data doesn't have the problems that you saw in that cognitive bias codex that you saw before. Historical data is measured and the actual pace that the organization that's going to be delivering the next piece of work delivered the previous piece of work. So this talk is about how to forecast using that historical data as a reference. How big, how long, how much. So let's go through some simple tools that I've made available to help you answer these questions quicker than you would have. How big? Understanding the size of a feature with less effort. Here's the simplest thing you could start to do. Every time you finish a feature or a story, the feature in this case, grab a post-it note, write the feature name on it, and write how many stories or how many story points it eventually took to deliver that piece of work. Find a big wall, stick it on the wall. In this case, you see that there's feature 2 took 3 stories. Feature 3 is 7 to 15. It hasn't finished yet, so we're not sure, but that was our best guess when we started. Feature 1 is completed, has 15 stories. You get hit in the hallway, because it always happens in the hallway. I've got an idea for a feature. Feature 4, how long is it going to take to do? Come this way. Take that person to the wall. And Maria Oliveira is wanting to talk to me on Skype. And walk along with you or a couple of other developers, or just grab a couple of people. Walk along and sort of look for similarity between the features that you understand and the feature 4. And when you find it, say it's about here. And then have a look at what stories are around it. You see feature 3 was 7 to 15, roughly 10. It's going to be less than feature 1, which is 15. So it's quite okay to say that the size of this feature is between 10 and 15 stories. So that's what we're going to try and do here. This is called reference class forecasting, and it seems too simple, seems too simplistic. It seems like it shouldn't really work. But there's a lot of research that says this type of reference class forecasting outperforms asking people how many stories would be in feature 4 alone without any understanding of the system and the context and the history of what you've actually done. So it's a very simple thing to do. I just don't want you to throw away the post-it notes. When you finish a feature and normally you have a party and you sort of throw it in the bin, grab it and walk it over to a feature wall and use it to do this sort of very affinity estimation on the fly. And if you get good enough at it, what happens is the person who gave you the question will do it themselves. They will walk up and sort of saying, looks like last time we implemented a Visa card new provider, it took us about 10 to 15, 7 to 15 stories or 15 stories. So they already have a rough idea of how big it's going to be without you helping them out. But say that's not good enough. Say that you're not going to, you want to be a bit more computationally aware. So what we can do, and this is a technique I use a lot, it's about, especially where there's these huge initiatives, that people want to implement, and they're massive. What happens is you have a whole heap of epics and you pull the whole team together and you make them sit down and break the epics down into stories, and then you have them estimate the stories, and that takes weeks and weeks and weeks. And as a consultant, I'm not against things taking weeks and weeks and weeks, but it is unnecessary. Often what we do is if we just break down a subset of those epics, a pattern emerges that we have some small, medium, and large size epics that come down to maybe 5 stories, 10 stories, and 20 stories. But that pattern of 5, 10, and 20 stories perpetuates through the rest of the backlog because the people writing the epics and the type of website that we might be redesigning or redeploying is similar it just breaks down in similar aspects. So I built a little simplest little sort of Excel spreadsheet. There are no macros in these spreadsheets. Everything's just done by formula, so it fails to be called complex. This story count forecaster, what you do is you might list all of your features, but you only have to put in samples for a couple of them. So what you do is you find some way of picking these features at random, and you have to pick them at random, otherwise you would cherry pick the easy ones. But if you pick them and truly pick them at random, and then you got the team to estimate the number of stories for just the features that you picked at random, you only need a few, and I'm saying 3 to 5 of them, to actually then generate a pretty good range of between 73 and 85 stories if we were to do 15. So this spreadsheet, what you do is you sort of say, you put all your features in, and then you just put samples in of the number of stories or the number of story points for just a few of the features, and then you can come in here and you can make any number that you want here, and it will tell you how many stories and that many epics or that many features. So what it's doing is, yes, you're going to do some of the work of breaking down the stories of the epics, but you don't have to do them all. And one company I went to had 340 epics to break down. And they didn't need to do 340. So this is a very quick way of using, if you've got these features historically, then you can pretty much look at how many features you have in the future and not actually go and break down any more work. You could actually use the actual counts that you got from previous features and epics that you've delivered. So this is a way of using your historical story count or story point data for a feature, summing it up at the end once it's done, putting it into this spreadsheet, and giving the business a tool where they can actually put in how many other features do you want to do, or how this project or initiative is 15 features, and then you'll get a story count. How good is it? And how many samples do you need? Well, the minimum is about 5. 7 is acceptable. Once you get above 11, you're on diminishing returns. Can I prove that? Well, this is the company where I did it. They had 36 samples, and it worked out, computed that there was going to be 500 odd stories. I then just picked 10 samples out of those 36, and I got an answer of roughly 500. I then cut down and deleted all of the other samples until I just had 3 remaining, and the answer was roughly 500. So once we had 3 epics broken down, we got the same number as after we broke down 36 epics, both actuals and computed. So this often stuns people when they sort of say, oh my God, that's not enough data. You can't really make big decisions on something like that. Well, built into that spreadsheet is a little tester for you. What it does is it gives you roughly, it picks 2 random groups in the data that you have and sort of compares them and says, yeah, these 2 random groups gave the same result, plus or minus 13% for 8 samples. So you just keep breaking down epics until you get that number roughly down around 10, and you're good to go. And then you'll know, once you do start doing the work and you see what the actuals were for what you put down, you enter that in and it'll sort of keep correcting itself. So faster way of breaking down huge epics, features and initiatives down into, we're just sort of doing a couple of items. How long? You now have a rough idea how big some feature is going to be. It's going to be roughly 500 odd stories. What can you do with that? Well, now you know that the system that you have for delivery, if you could know the rate that it actually completed work, then it's a simple division operator for how long it will take to deliver 500 items. If you could do 100 items a week, it will take 5 weeks to deliver those 500 odd items. So that's what we want to do here. We want to actually be able to take a rough size and convert it into a rough time of how long it's going to take to deliver through the system we're doing. The data we're using to do this is historical data about how fast that the team delivers, or an estimate of how fast that the teams are going to deliver. There's a spreadsheet for this. Again, absolutely no macros. This is just a straight spreadsheet with formulas. Fails to be called complex. But what does it do? It starts off by just hypothetically saying, what's my starting point? And often we don't know exactly. It's between 20 and 30 stories. So this type of forecasting, called probabilistic forecasting, what it really allows you to do is add and combine. It's the addition operator for uncertainty. It's that, well, we got this unknown plus this unknown plus this unknown. That's what probabilistic forecasting is for. It's called Monte Carlo forecasting. It's just simply the addition operator of range estimates, of ranges of values. Rather than just a single value is the plus operator, Monte Carlo is the process we use to combine numbers as a range. So the process it does is it just keeps hypothetically using the samples that the team has historically released on, 10 per week, 5 per week, 3 per week, and creating hypothetical burn down charts until it hits the axis of completion. And it does that 1,000 times, so there will be 1,000 little grey lines here. And what that allows us to do, if there's 1,000 grey lines, we can sort of say, well, 850 of them were on or before the 17th of June. So we have an 85% chance of delivering by the 17th of June. So because we had uncertainty in, we get uncertainty out. And the way we resolve that is by picking how much risk we want to sort of take, less likely or more likely, more luck or less luck. And we see it sort of saying the 85th percentile, which just means 850 of those 1,000 made up bits of data actually delivered on or before a certain date. And that's all it does. Now, when we just take the average throughput or velocity and divide it by the average story points velocity, we end up with one that's right here, roughly in the middle at 50%, which is great, but it means we got a coin toss chance of being early and a coin toss chance of being late. So by combining it in Monte Carlo, what it allows us to do is sign up and agree on how much risk we're willing to take on delivery so that we get it right more often than 50% of the time. So that's what this is all about. It's a way of actually dealing with the uncertainty that we know about, but communicating a date nevertheless, or a duration nevertheless, as we move along. It's a pretty simple thing to use. You just give it a start date. You give it how many stories there are, 20 to 30. And down here it says, we don't have any data yet. This team has only just been formed. We have no history of it. So let's just start as saying that it's between, they agree that as a team they'll get at least one thing done per sprint or week. And they agree that the best they're ever going to do if they had a rocket sort of week would be 5 items. Again, so this spreadsheet is combining this uncertainty with this uncertainty, simulating all those burn down lines, and then just sort of saying 85% of them were on or before the 17th of June. That's a probabilistic forecast. And what it helps us do is, what it's really doing, and the simulation is good and all, but it's actually documenting all of our assumptions in one place. A lot about these models is about you showing that you understand the system of delivery that you're working with. And initially, and when we start getting data, what we're really doing is we're saying, if we get weeks where we get nothing done, or weeks where we get 20 things done, then this forecast is immediately questionable. Use these tools as a way of documenting the assumptions that you're making in forecasting so that you can quickly understand when you're going wrong. So this is pretty good. And again, I'm saying you would communicate it, this is an 11-week project. You wouldn't communicate this date until you knew exactly that you had a start date to go off. And we'll get back to that in a second. But I don't want you to use that spreadsheet. That's enough for you to sort of understand how this is working. I don't want you to use it. And everyone says, well, why don't you want me to use it? It's because whenever someone asks you when something will be done, they already have a date in their head, and all you can do is disagree with it. All right? What you really want to do is use this spreadsheet multiple feature forecast. Why is it different? What this spreadsheet allows you to do is to actually ask them what their target date is. So when they say, when will this be done? You sort of say, when do you want it? And then you just sort of put your hands on your hips and you look like you're a millennial. And they have a date. And if they won't give you a date, make one up. Make one up in 3 months' time. Make one up in 6 months' time. Because what this spreadsheet allows you to do is to break the features out. And it will tell them what's going to make or not make, or is at risk of not making that target date that you want. This is the discussion you want to have. The discussion you want to have is the start order. In other words, no, I really need feature 4. We can't not have feature 4. Say, well, then we'll start at 1. Change that 4 to a 1, change that 1 to a 4. And then they'll say, oh, but feature 1 was pretty good too. And you're sort of saying, well, do you need all of feature 1? Can we split feature 1? Can we split that into just enough of feature 1 so that you'll get some of it? Because the moment we made that change, you would have lost feature 1. It would have fallen off the bottom of the backlog. This is healthy discussion to have early, before you start. Not once you find out that it's late and everyone's disappointed. Not once they've been told that they're going to get all 5 features and communicated that to the market. You need to be doing this debating before you start, before commitments made. And you need to do it in a way that they trust. And the way you do that is by saying, this spreadsheet is using the historical rate that this team delivers. So if we don't do something about how that team is delivering, this is going to be the outcome, sorry to say. So I've tried to turn the conversation around into you getting the date that things are needed, and then turn the conversation around to what's going to make it, change the order when something misses, ask them, you got this 20 to 30 size feature 4. Do we need all of feature 4 like that, or can we do part of feature 4? Where does the value truly lie? And there might be a part of feature 4 with the most value, which is only between 5 and 6 points, in which case you get feature 1, 2, 3, and 4, the part of 4 that's most valuable. So this spreadsheet is trying to help you have the conversation. And forecasting isn't about the mathematics or the result, it's about the conversation. Remember I said the context of which route I'm going to take? This is discussing the route that you're going to take at a business level with your significant business other, your stakeholders. Okay, so there are 3 tools. One to give you how big quickly, one to give you how long for an individual feature, and one to give you the way to have a conversation around what's going to hit a target date. Now, all of those can use the historical throughput or velocity that you just capture from the team week or sprint after sprint. And by doing that, you're sort of saying it's not my estimate, this is what's actually happening in the team. So the reasons I don't get hired back to some places. Every one of these is a reason why one of my outcomes turned out adversely, why something went wrong, something that wasn't right to me. And the biggest one, by far, is that the start date that people assume a project or initiative is going to start never happens. It happens on paper, it's written down, and it's assumed that it's going to happen. And you've even given a completion date based on that fictitious start date. But you need to define what start is. And start means that the team is present, that you can actually physically see them, that they're not still working on the last release because it didn't go to prod cleanly, that they're trained and know what they're going to do on the new work. It's no good just having people going through induction and then sort of saying, well, now they're going to be full members of the team. You need to know that they know what they're going to deliver, that the vision, and they understand the way that the stories are written, that they can work independently and not immediately be blocked by 100 questions which are going to inhibit them doing work. So here's the thing. I've not seen any project or initiative where the full team is available on day one. So if you are in that situation, you shouldn't be using the historical throughput or estimates, assuming that you have a team that's under capacity. You need to really look at which teams, what capacity you actually have. Here are the risk factors. If you have superheroes on your team, you're under strength. And it sounds insane, but I've got the superheroes. But everyone knows you have the superheroes. They're the first people that get borrowed for a production outage. They're the first people that have to go and train new staff or do inductions. They're the ones called into meetings and planning meetings. You don't want the superstars. If I see a team of superstars, then I already know that they're not going to be full-time employees on my team. So think about it. Know how long it takes to train up new staff members on different skills that you need. If I could get one bit of data in a company, it would be that for our website, for a front-end developer to get up to speed on how we do our template and bootstrap sort of CSS, it will take 6 weeks. I know that this start date is questionable until at least 6 weeks into the project. So I wouldn't assume that they're going to operate at full speed until then. So this is the second biggest fail. Now, it sounds easy to do the Monte Carlo forecasting. It's a very simple algorithm. All we're doing is randomly generating hypothetical burn downs, okay? What could go wrong with that? Well, when we're talking about features, when we're in discussions about what features there are, it makes sense to talk about them as a group of work, and we call them a feature. And then when we break those features down into stories, we're assuming that they're a size, and we're still talking about them as an abstract artifact. We haven't actually started coding yet. But the way we like to talk about stories in planning is not the size that's best for a developer to implement those stories in coding. We often split them more when they get into the team. Rightly so, and you don't want to inhibit this. You don't want You don't want the team picking up a story that was great to talk about in planning and then try and code to it because it's too big. It will miss a sprint. It won't be able to be tested well. So you want to allow stories to be split, but this is what happens. If you measure the throughput, and this is the throughput measure that you get when they're in these smaller segments, you would appear for this feature to be moving twice as fast as you are because you're saying you're getting credit for doing 2 stories, but really you just did 1. And down here, you're getting credit for 1, 2, 3, 4 stories, but really you only completed 2. And up here, you got a credit for 6 stories, but you really only delivered 3. So you will appear to move a lot faster than you actually are delivering the way the stories were described during planning. And this has unfortunately been coded into many of the tools you'll see on the market. If it automatically takes your throughput or your story point rate from the completed pile, it's measured in kilometers per hour. If you then divide that rate by what you have remaining in the backlog, that's in miles per hour, you will be going a different speed. It's just a unit conversion problem, but it's been built into many of the tools. And it means that you will be out by roughly a factor of 3 times. Or in this case, 2 times. In this case, it looks like you're getting 12 items done a week, where really you only got 6 items done a week. You must adjust for it. In my spreadsheets, there's another field which you just put in the split rate for work, somewhere between 1 and 3. If you don't know what to put in, it's always between 1 and 3. And I have people say, no, we don't split our work like that. It's like splitting is a bad thing. It's not. It's quite healthy and productive for the developers to code at a scale which makes sense to them. But if your throughput also contains bug counts and defects, then this could be up around 5 times bigger. So this means some items don't get split at all. They get done in the same unit. And this means some items get split. A third of the items get split not at all. A third of the items, 1 item becomes 2. And a third of the items, 1 item becomes 3. Stories are split, 1 defect per story, something like that. So this is it. If you don't do this, or if you're not doing this, or if you're just taking your velocity that you have in a backlog, not using my tools, but dividing it by what's remaining in the backlog, so you took the velocity of completed and divided by the remaining backlog, you'll be out by up to 3 times, at least 2 times. So that's the big cause I see of why most projects fail or most planning systems fail. Don't fall prey to it. And if you did use that story count forecasting spreadsheet, the first one I showed, and you put in the actuals after the fact in that spreadsheet, what it will do is it will actually give you the numbers to put into the other spreadsheets for you. But it's a big fail. I guess fail 1 often puts projects out by a matter of months, 2 to 3 months, because it's almost approved, or the team's almost ready. This splitting often puts projects out by 3 to 6 weeks. Fail number 3. This one is that near the end of projects, some things we thought would work don't work. In my coding era, it was always IE6. It would work great on Safari and Netscape or Firefox or Chrome, and then there was something in the users were told that they didn't have to upgrade their Windows XP machines, which are going to have IE6 installed. And now you spend weeks at the end of the project trying to get IE6 working without breaking the others, and it was a fight. I don't know what it is now. It's a Safari. There's probably another round of different sort of types of browser compatibility issues. In the US, there was the great debacle when the Affordable Health Care Act went live, and the website, everyone in the market had exactly 2 months to choose their new health plans. So the website was ready just in time for that open enrollment period, and it failed under load. And that was quite embarrassing. These things are going to happen, and you always have between 2 or 3 things. And a risk in my world is it's work that you might have to do, but you're not sure yet. It's not anything else to do with that, well, the market may not take it. That's product risk. What we're dealing with forecasting risk is that there's some work that might need to be revisited, or there's some work that we might have to do to make this work in production. Get the config files automated, get it containerized. And what does it do? It means that if you didn't have any risks at all, you were looking at around about sort of a 27th of May journey, release. And in this case, there's, if we have some browser compatibility issues, we think it's going to be between 7 and 10 stories to retrofit and fix that. 40% chance that it's going to fail under load, and a 30% chance that it's going to have production configuration issues. Someone needs to be looking at how you can reduce these likelihoods. This stuff is pretty much fixed. You can't really change it. What you can control early in the project is saying, let's do performance under load testing early and prove that we don't need an indexing server or a new caching sort of instance to try and solve the performance issue. And if you do keep these under control, your projects will deliver when you expect them to. What happens is a lot of these risks only get found right at the end of projects, and it takes a long period of time to sign the project off. Another one of these which happens is who signs off that your project's allowed to go live. And that matters a lot. There was one instance where it was a new credit rating system going into a region, and the region said that they would not allow it to go live until 100% of the individuals' credit ratings were exactly 1 for 1. There were 5 million people in that credit rating. So it was okay for just one person to get a different credit rating value between the two systems that inhibited release. It went late about 3 years over, and they had to keep the team on the payroll for that period of time because they didn't know who was going to fix it. So what happens when you add these risks in is you see how this tail starts extending out, and where you went from an 85th chance of getting 27th of May, really it's 24th of June with the risks included. So, I find that risks pretty much make up about 1 month, 4 weeks worth of possible variation. So if someone hasn't done a risk analysis, I add a month to the estimate. And then I make them tell me why that's not going to be the case. Risks, an enormous factor for you to get your handle on. And here is the root. Here's the root of all those fails, really. This is the one which is you need to manage, and you're in control of sort of managing. Who can estimate how long it's going to take them to commute from home to work? The bicycle or the cars and motorbikes? So even though the bicycle would travel slower if this was a free-flowing sort of road, at the moment, that person is in control of their speed, and they know that they're not really going to be obstructed by much at all. Everyone stuck over here in this traffic have no clue. What was the prime factor about when they will arrive at work? The time of day they left. If they left during commute hour, rush hour, they're going to get to work much, much later than if they left at 1 a.m. in the morning. And this is what tends to happen, is that we have this utilization curve which sort of says that once we get above 80% utilization, our queue time grows exponentially. And this has been written about a lot by people like Donald Reinhartson in Principles of Product Development Flow and books like that. It's known. Now, the problem is that once we get into high utilization, it really doesn't matter what work we're doing. We could be in a sports car Ferrari here, and it wouldn't go any faster than this little dilapidated motorbike here, this little Honda. So in high utilized systems, it matters less the piece of work that you're working on because you're being impeded by the rest of the system. But if you keep your utilization below 80%, where you can handle variability in the sizes of items, then estimates would actually match actual time much closer. Unfortunately, does anyone run a team in anything other than 100% utilised? I've seen reluctance of management to sign off on that, even though that they could understand that it's beneficial, that the impact of high utilisation is on lead time is astronomical. It is our biggest problem, which is why we introduce WIP limits. We do WIP limits to try and cut down the utilisation to something that's controllable. So you can't forecast any method. There isn't a single method that you could use to forecast a system which is over in this region of congestion. It is not possible because it has nothing to do with the work that you're doing and everything to do with blockers and things that are impeding workflow. The system rules. So over here, you're trying to estimate the system, and over here, you're trying to estimate the work that you're going to put through that system. And it actually, the math behind this curve is actually something called the Kingman's approximation. And it just, I don't want you to care about the formula at all. I just want you to focus on these two bits of uncertainty. There's arrival time variation and cycle time variation. Now, we're very good in Lean and Kanban about managing our service time, our cycle time variation. We do everything we can to make things go and flow fast and smoothly. The problem is that if we don't control our arrival time variation, all of those cars and motorbikes arrived at the one time for that piece of road. If they were distributed over the whole 24 hours, we would not have seen congestion. So you have to have a way at controlling arrival time variation if you want to stay out of this high impact zone. WIP limits, limiting your WIP is the only way you can make arrival time exactly consistent. So WIP limits give you the double benefit of reducing the cycle time. It really reduces the cycle time because it stops you getting up into this elbow and this exponential region of how long you have to wait and stand idle before you can get to move. So there's very good business reasons to actually limit the amount of work that you feed into a system. And this is what happens if you don't. This is the throughput for 100 teams for a large company. And you see, over time, they roughly sort of were getting slightly more and more work through. And then around about Christmas time, they have this complete decimation of throughput. And it's severe. So for roughly 3 or 4 weeks, they get nothing delivered. And, everyone's scratching their head on this and sort of saying, well, not that many people are away on vacation. All right. The reason for these drops was a HR policy on annual leave. Nothing to do with the system, nothing to do with anything in control of the teams. It was the fact that if you didn't use your annual leave, you lost it at the end of the year, calendar year. Now, I calculated the impact of this lost delivery period, and it comes out to being about $500 million. A HR policy was costing the company $500 million. Nothing you can do in estimating poorly, nothing you can do about arguing whether something is a 3, 5, or 8-point story is as significant as a stupid policy or HR. And even if you were going to forecast using this, which trend would you use to forecast? Would you use this trend or maybe this one? This is where there was a rumor of a reorg. This is when the reorg happened. It's chaos for a while as the teams were starting to reform. When I joined, that was when I left. Not really, but how good would it be? But there's all these variations in the system which have nothing to do with the teams. Now, the reason this one's interesting is we often look at throughput and saying metrics were used to abuse teams. Well, it's not the case. What these types of charts show is that if every team is trending adversely, then there's nothing you can really do in the process or forecasting to understand that. But if you were forecasting a project that went over the end of year break, then you need to null out January. Or if you have a project in Europe, you need to null out August. nothing's going to really get through in those periods of times. So when we're doing our forecasting, we do have to take a step back and look at the big picture view and understand the environment, which has nothing to do with the pieces of work. So if you're working in systems like this, where the system is influencing more of the time, this went to zero not because 100% of the staff were away, that just enough staff went away to throw us into that high utilization curve. So nothing got out because we went from, the people who were there were so saturated that there was huge queue times and wait times to get anything through the system. So this is where no estimates has a point to make. There are some systems where it's pointless knowing whether something is a small, medium, and large because it's dwarfed by the influence of the system itself. And that's why we need to look at ways of forecasting at a system level. And the way the spreadsheets I've shown you do that is they look at the history of the rate that items are delivered, and they use that history as a way of forecasting the future at a system level. But they don't ask you how many small, mediums, and larges of those items, because essentially it's in the noise. You wouldn't even see it as a fluctuation if you did all larges or all smalls. Now the problem is often we do forecasting using cumulative sort of trends, cumulative flow diagrams or burn ups or burn downs. And those same periods look not as severe on a cumulative style chart. Be careful of that, because if you're doing a 6-week project and it went across December to February, it's massively impacted by these incidents. So think about it. You've got to use the right tool for the job. The spreadsheets that I've given you use the data of throughput, and they're really good for really short-term forecasts. If you're doing long-term forecasts and projections, then by all means, look at the general trend of an organization and just extrapolate that forecast line out, and you'll understand what capacity you're going to have in a period of time. But know that if you use this technique for that, it's going to be wrong. And if you use that technique for this, it's going to be wrong. So you've got to really think about whether I'm doing a longer-term forecast. Anything over 6 months to 9 months is a long-term forecast. Then you want to look more at a cumulative diagram. But don't go using those lines on a cumulative flow diagram to forecast the next week or the next couple of weeks, because there's too much variation for it to handle. So this is the key takeaways. You've got to look at the system level view. If you just look locally, or if you just look at the work itself, you're missing a whole aspect of why the organization isn't going to be able to meet the forecast that they expected. Just remember that often three samples, if you're breaking down 3 stories, will be better than story poker estimating 100 stories. Because the planning poker has every individual's cognitive biases engaged, whereas the actual measuring of a system actually uses real data. So use sampling in preference to intuition. If you're going to give a forecast and you're going to set the team down to discuss how you're going to achieve something, present multiple options. Don't go just presenting the one that you eventually decided on, because there could be context you don't know about yet, or that context could change. Remember to write down the start conditions. Don't give an end date until you know what a start date is and you know what defines a start date. Stick with just durations. And always what you can do to test these systems is, even if you have data up to today, delete the last 3 months of it and see if the data you have would have accurately predicted where you got to today. Always compare those actuals with what you have. So don't trust the model until you can prove that it can forecast something that you know to be true. And once you've forecast that you know to be true, feel engaged to be able to forecast forward. So that's it from me. You can get everything from this URL. It's my life is up on GitHub. It's all free. There's a lot of single-page explanations and books and stuff like that there. I love feedback on it, and thank you.